Let's have some more fun sketching parabolas using our graphing form of a quadratic equation. So what I've got here is a quadratic in descending order, and I'm going to separate these two terms from my constant term. I will do that by just rewriting it as 3x squared plus 12x, and I'm going to separate the plus 13. Now, if you remember that in order to complete the square, what I need to have is a coefficient of 1, and I don't currently have that, but I do know that 3x squared and 12x both have a 3 in common, so I can factor out a 3. That'll be my scalar, and I'll get that 3 times x squared gives me the 3x squared, and 3 times a positive 4x will give me the 12x. I'm going to leave some space there and have my 13 outside the parentheses. And so now that I have my my coefficient of 1 on the x squared term, I can do my completing the square rather. So I'll take half of this number here, which is 2, and square that. So I'll add 4 inside the parenthesis. But notice, when I'm adding 4 inside the parentheses, because this 3 gets multiplied through, it has to be distributed to get that 3x squared and get to that 12x. I'm not just adding 4, I'm actually adding 12. 4 times 3 is 12. So in order to add 12 in here, I need to subtract 12 from the outside. And that will then give me my my constant term. So this 3 stays right where it is, 3. I can now factor my perfect square trinomial inside here. That'll be x plus 2 quantity squared, and then 13 minus 12 is a positive 1. So that means that my vertex will be at negative h and k, or in this case it'll be the opposite of that number there, so negative 2, and the k is 1. So I have a vertex here at negative 2 and 1. There is my vertex. Since our axis of symmetry passes through the vertex, passes through there, then our axis of symmetry is along this line here where x is equal to 2, negative. X is equal to negative 2. That means whatever I do on the left side of my equation, of my graph, I have to do the same thing on the right side. So let's see how it looks. Since I now have a scalar of 3, then were I just to go input 1 for x squared and get a 1, but now I have to multiply that by 3. So my next point won't be here, it'll be 3 times that. So it'll be 1, 2, 3 there. So my next point is here, and because I have to do symmetrically on the left side what I do on the right, then I have a point there as well. And now if my third point would be, or my fourth point would be 2 and then 4, then I'd have to multiply that by 3, so that would take me all the way up to 12 higher. And again, that's going to be really, really high. So we won't draw that, but notice that my parabola now is really, really skinny. It's really, really skinny. And it goes along that axis of symmetry. This scalar of 3 is what makes it nice and skinny. Let's take a look at another parabola where our scalar is going to make it behave a little bit differently. Here I'm going to again separate these two guys, and I notice that they both have a negative 2 in common, so I'm going to factor out a negative 2, and that'll end up being my scalar. Then I will have x squared. Now a positive divided by a negative is a negative 5x. Leave some space, and we will subtract 7 from it. Alright, so let's give some space over here so we can play. Alright, so now I need to take half of my middle term, which is 5 halves, square it, so that's plus 25 over 4. And now I'm going to multiply that by a negative. So we're adding here, so we would subtract, but a positive times a negative gives me a positive 25 halves. If that gives you any trouble, you need to pause this video and play around with multiplying 25 fourths by a negative 2 over, or negative 2 over 1. So if that's 25 halves, then this is going to be a 14 halves negative. So plus 25 minus 14 gives me a plus 11 halves on the outside, whereas my squared term is going to be x minus 5 halves quantity squared. The negative 2, I'm just writing things backwards, and that will be my f of x. So now how do we graph that? Well, my vertex is at 5 halves and 11 halves, so that's going to be, let's see, 5 halves, that's 2.5, so about 2.5, about here. And then I go up 11 halves, that's 5.5. So that'll be somewhere, let's see, 1, 2, 3, 4, 5.5. This is not exact, but it looks like it's somewhere in that neighborhood. That's my vertex. And my scalar this time is negative. So I'll need to go down. If I went 1, I'd have to go 2 because my scalar is 2 negative. And so my parabola would look something along these lines here.